Okay, I'm going to show you how to calculate the percent error. So this is something that we use in lab to tell us about the accuracy of our results. So percent error is calculated by taking the absolute value of the experimental minus the theoretical value over the theoretical value times 100. Okay? Now, because we're doing the absolute value of this difference, it really doesn't matter which way we write it, whether we do experimental minus theoretical or theoretical minus experimental. If you subtracted it either way, you're going to get the same result since it's absolute value. So let's look at an example. So if a student measures the mass of an iron bar to be 5.86 grams, and the actual mass is 5.92, and we want to find the percent error, first we have to identify what's the experimental value and what's the theoretical value. Now notice that this problem hasn't used the word experimental or theoretical, but we have to use our context clues to figure it out. So if the student measured it, that's what they did in the lab, that was their experiment. This is our experimental value. And when it says the actual mass, that's the true or theoretical value. So this is our theoretical value. Okay, so given that, the percent error is the absolute value of experimental minus theoretical over theoretical times 100. So it would be the absolute value of 5.86 minus 5.92 over 5.92. This is where people tend to mess up a little bit. They forget which one to put on the bottom. It's always theoretical times 100, so that when we take the absolute value of that, we get 0.06 divided by 5.92 times 100, and that would give us 1.01% error. The lower the percent error, the more accurate the experiment. So I would say that this is a pretty high degree of accuracy, which makes sense because the student was just measuring mass of an iron bar, right? So that should be pretty accurate. The more complex the experiment, the higher the percent error is likely to be.